again, sort of blown up with speed. I should actually be talking about antibody orbitals, but that bothers people who do that years ago. So I just showed the body orbitals. So there's some kind of a hybrid orbital here, right, that is being used to bond that hydrogen to the carbon, in this case an sp3 hybridized orbital. And the base is coming with his, whatever kind of orbital it is, p orbital, hybrid orbital, something with various pair of electrons. And as he's starting to attack the proton here, so he's starting to snatch the proton off, the pair of electrons here, this hybrid orbital here and the hybrid orbital next door begin, as they overlap here, lined up like this, I can start to form a pi bond. So here we're sp3, in the product we're sp2, sort of like, you know, sp 2.5-ish, you know, meaning as you hit the transition state, as you hit the go, no-go point, the transition state, this pair of electrons is being used to hold the carbon, the hydrogen out of here in a sigma bond, is beginning, that hybrid orbital is beginning to come up like this, and it's changing character from a hybrid orbital toward p orbital. And this bond angle, which is currently approximately 109, these groups here are starting to come up. It's starting to flatten out. This bond angle here is starting to approach 120. These bond angles are starting to approach 120 as this thing is starting to come off. And then as it comes off completely, and this thing flattens out, these things here, whatever they are, the things that are down here, whatever they are, this thing here and this thing here, have moved up and are now coplanar here like this. The substituents here, whatever they were out in the front, out and up in the front, and out and back. Like that. Up and out and up and back. Those guys are moving down, and in the final product, they're flattened out. And the final product is planar. So the only way for this to happen smoothly, there are actually two possibilities. But the most common one is that the beta hydrogen has to be anti-periplanar to the lead. Is that staggered or eclipsed? Staggered. And the orientation of the hydrogen to the leading group is anti-180. Anti. And they're approximately in the same plane. Anti-periplanar. That's the only way that this hybrid orbital can smoothly morph into a p orbital and form a pi bond smoothly. Well, there's one other way. Synvert. Very rare. Meaning, the base could come to take the beta hydrogen, to form a double bond, and kick the leading group out, because if that happened, although I would be doing a better job with, as I said, antibody orbitals, but as I said, as you start to imagine this happening, as the base is starting to take the hydrogen, and the pair of electrons here is starting to usually form a pi bond, and the leaving group is starting to depart with those, I again am going from an sp3 situation to like sp 2.5, cleanly to sp